Hello and welcome back to Apt for You. In this particular video, we will be discussing a new problem from linked list, and the problem basically is from Geek for Geeks. The problem says that we have to perform rearrangement of the linked list, right? So basically, we have to rearrange a linked list. As for example, they have already given an example wherein see we have a linked list with elements 1, 2, 3, and 4, right? So this is the linked list 1, 2, 3, and 4. By the definition of rearrangement, they basically want to say that we have to bring all the nodes in the odd position together, all the nodes in the even position together, and give a resultant array such that we will have something like 1 followed by 3. So all the odd position nodes are together followed by all the even position nodes. I hope the point is clear, right? So you can see 1, 3, 2 and 4 is the output. Similarly, if we consider another example, so there also they have done the same thing. If we see the example, we have some elements like 1, 2, 3, 4 and 5, right? So 5 nodes are present in the linked list. Now what happens is basically we have some nodes in the odd position, some nodes in the even position, right? And numbering starts from 1, right? They have given in the question. So basically this node is odd, this node is odd, this node is odd, right? And 2 is even, 4 is even. So what should be the output? The output should be all the odd position nodes should be together. So basically 1, 3 and 5 should be together. 1, 3 and 5 are together, followed by the nodes in the even position, so 2 and 4, right? So I hope the intuition of the problem is clear. Now what is the approach to solve this particular problem? So we shall see how can we solve this particular problem. So let us suppose we are taking this example of 1, 2, 3, 4 and 5. So now let us just zoom the screen. Alright, so the setup is complete. Now let us solve the particular question. So what we shall do is basically we shall take the example of linked list 1 followed by 2 followed by 3 followed by 4 followed by 5, right? We are given the position of the head node and we have to give the output 1 followed by 3 followed by 5 followed by 2 followed by 4 and followed by null, right? This is the output and this should be my input, right? So the problem is how to deal with this particular question, this particular case. Now before we proceed, we should focus that we are given the head node, right? Now they have also said that the length of the linked list starts from 1, okay? Length of the linked list starts from 1. So I have to basically deal with the condition also wherein I have only one element in the linked list. Suppose this can be one of the linked list 1 followed by null. So in this particular case, what should be the output? The output should be same, isn't it? Because we don't have to perform any changes. So for that particular case, what I'm going to write here, I'm deal with those cases where we don't have to do any changes in the linked list. So basically, if my head is head next, so head next is equal to null. This is one of the case when I don't have to do any modification of the linked list. And is there any more cases? Definitely there is one more case. If our linked list has two elements, 1 followed by 2 suppose, followed by 5, null. This is null, okay? So in this particular case also we don't have to perform any modification of the linked list, right? You see, because the odd positions are already in their position and the even position node are already in their position. So basically we already have achieved the configuration odd nodes and they are followed by even nodes, even position nodes, right? So in this case also we are not going to do any changes in the linked list. So this case also basically we will write and when heads next is equal to null, right? So heads next is equal to null. This is one of the condition when we are not going to perform any changes. So we will write head next equal to null. So these are the two cases wherein we are not going to perform any changes in the linked list. So what we will do, basically return. Remember, we are not asked to return head. We just have to make the arrangement, right? And everything will be done itself. We just have to configure the linked list. That's it. We don't have to return any head. So that's why I'm just saying return. I'm not returning any value. Moreover, this particular function is also void type, right? So we are not basically going to return anything. So just return, simple return. Now, if suppose there is no linked list like this and no linked list like this, so definitely we cannot say return, right? We have to solve that particular linked list. So for that, let us consider a good example of this linked list, okay? This is our linked list, suppose. How to deal with that particular problem? So we shall basically take the use of, we shall make the use of few pointers, right? So I will take the help of some extra pointers that will help me to code this particular problem. Those pointers I will be declaring here. So struct node star p1 comma star p2, right? And I'll just declare one more pointer that will point to the head node, okay, the even head. Let me write here even head. Okay. Now what we will do is basically p1 will point to the head node and p2 will also point to the heads next. Alright, which means that initially my p1 will point to the head node because this is my head node, right? And p2 will point to the head next. What next? Even the even head, basically the pointer even head will point to the head of the event node position. So basically this is the event node, so the first node of the event side, isn't it? And this is the first node of the odd side. So first node of event side is 2, this one. So this is basically nothing but head next. That is why event head will also be equal to head next. Why am I using this? This will become more clear at the end. Now what shall we do? Now it's time to configure the linked list. So for that purpose what we are going to say, while p1 is not equal to null, okay, because it should be a valid node, the first node, and p1 next is not equal to null, again it should be a valid node, and p1's next is not equal to null, right? So I am writing not equal to null for for clarification. You can just write while not p1 also, right? But for clarification, for easy understanding, I am writing the complete thing. For while p1 is not equal to null, and p1's next is also not equal to null, and p1's next is also not equal to null, then we will basically enter the while loop. Entering the while loop. What should we do now? Right now, if you can see, p1 is at this position, p2 is at this position. So basically, we should say p1's next should be equal to p2's next, right? So p1's next should be equal to p2's next, right? So we will write here p1's next is equal to p2's next. Done. What is the next thing we should do? Next thing we should say, update the position of p1. Basically now p1 should point. So you just see, just now we did p1's next is equal to p2's next, which means we got 1 followed by 3. Done. Now update the position of p1 to its new position. So basically p1 equal to p1 next. So what will happen? Basically now p1 comes this position, right? So p1 equal to p1's next. So p1 was right now in 1 and we can see p1 is here. So p1's next is nothing but 3. So p1 will now point to 3. Now update the next link of p2. So now basically p2 should point to what? 4, and 4 is nothing but p1's next. That is why I am writing here p2 is equal to p1, sorry, not p2, p2's next equal to p1's next. So basically we can see we have successfully achieved these two configuration, 1 followed by 3 and 2 followed by 4. What should we do next? Next now, see p2 is at this position, right? P2 is at now right now pointing to this node. P1 has now pointed to node 3 and P2 is now pointing to node 2. But remember, we should update P1 and P2 such that they are pointing to the last nodes of their respective linked list. So basically P2 should not come to its new position. That is why I will write here P2 equal to P2 next. Got the point? So I basically updated the position of P2 also. So P2 is also basically coming to this position 4. Now basically what happens? That's all. Now this loop will again go back. This loop will again go back. Again P1 is not equal to null, true. P1's next is not equal to null, true. And P1's next is not equal to null, that is also true. Right? You can see right now P1 is at this position. This is also not null. Its next position is also not null. Its next position is also not null. So again we come enter inside the while loop. Again we say P1's next is equal to P2's next. So P1 is basically 3 and P2 is basically 4. So P1's next means next of 3 will have what? P2's next. P2's next is nothing but 5. Done this line. P1 equal to P1's next. As I said you, always you have to update P1 to point to the end of the linked list. Again P2's next equal to P1's next. So now P2 is right now at 4 position and P1 we have updated to point to 5. Right now we updated P1 to point to 5. So better write it here. So you see this was P1 here and P2 was here, right? Right now what we did, P1 updated to position 5, and we know this is nothing but null. Then P2 equal to P1 next, what will it do? It will basically point P2 to null. Again, P2 next equal to P1 next. So P1's next, P2's next is basically pointing to this. So basically this is not the case. P1 has come to 5, okay? You see P1's next is equal to P2's next. So what did it do basically? P1's next. P1 was basically here at point 3. Its next is equal to P2's next. P2 was here and P2's next is 5. So 3 is pointing to 3 next is 5. So 3 and 5 are joined now. And we updated the position of P1. So P1 is now pointing to node 5. Done. Next is P2's next equal to P1's next. P2 is what? 4. 4's next will be what? P1's next. P1 is now pointing to 5. 5's next is nothing but null. So it is pointing to null. Done. Now we say P2 is equal to P2 next. So P2 now is now at 4. P2's next will now point to null. So P2 now points to null. Then we come back. When we come back in the while loop, the condition says P1 not equal to null. True, because P1 is non-null. But P1's next is not equal to null becomes false. But because it is actually null. So this will no longer enter into the while loop. Instead, come out. Now what should we do after we come out? You see, right now we have two different linked lists. One linked list has 1, 3 and 5. They are disconnected. Another linked list is 2, 4 and 5. My P1 is at this position, P2 is at this position. We know that we have to join these two, right? The odd nodes collection followed by the even nodes collection. So how do we join this? We know the address of this one. This is the first node of the even list. That was basically the even head, right? The even head is already storing this node's address. That is why I will write outside the while loop when it terminates that we will say P1's next is equal to even head. That's it, right? And the entire linked list will actually work. You can see our output is 135. We just got here, right? 135 and 24 should be the output. So let us see how this actually works. So I will basically compile this right now. So let me just clear the entire screen. Alright, let us just compile and see whether the code is working fine. So yes, compilation is successful. The output is also fine. Let us see whether submission basically passes all the test cases. I hope we are not doing that. Okay, segmentation fault. So basically we are messing up with null values. Somewhere I am 100% sure this is a slight mistake in case of null. Okay, here. So this should basically be OR, okay? Sorry for that. The reason why this should be OR is very clear, because we know that when either of these condition is true, we will just return. This basically refers to the case when we will have one node followed by null, and this refers to the case when we will have 1 followed by 2 followed by null, right? So if this case is present, then also this will return, and if either this case is present, then also this will return, and it will not do any changes in the linked list. Fine. So now it should work fine. Just compile and check whether it is doing good. So just waiting for a minute. Yes, fine. Submission. Yeah, that's it from my side. So the compilation is successful. The code is working fine. I hope the explanation was very helpful. In case of any doubt, please feel free to put your doubts in the comment section, and just like, share and subscribe for more such videos. Thank you.